Let's use the drawing we created in a previous exercise. Go to File Open, or you can press Ctrl O. Then go to our training folder, Desktop, Civil 3D Advanced Assemblies and Subassemblies, Source Files, and open Surface HAVA and XS. Then go to File Save As, or you can press Ctrl-Shift-S. Because we want to save it as a different drawing. We don't want to overwrite this drawing. This is the drawing which we will use multiple times. And go to our training folder again. Subfolder Training Drawings. This is the folder where we will save our training drawings. And save it as Codes and Code Set Styles. And save it. And this is our starting drawing. Let's create assembly. Go to Menu, Corridor, Create Assembly. If you prefer using ribbon, go to Ribbon Home, Assembly, Create Assembly. As an assembly name, we can use Road. As an assembly type, if you want to use a specific superelevation, for example, if you want to superelevate along the outside edge, along the curve or inside edge, or some other complicated superelevation, then you must specify the assembly type correctly. If you're going to have a normal undivided grounded road, then even if you use a type other, it will still work. But for now, let's use an undivided grounded road. As an assembly style, use universal style. As a code set style, we have 3 code set styles in this simplified template. There's an assembly, corridor, and corridor with links in plan. Of course, we want to use an assembly for assembly. Click OK and specify the location. If you want to, you can draw a rectangle around your assembly, so it is easier to find the assemblies in your drawing, but you can also navigate to your assemblies from tool space, so it is not that important. Let me zoom in closer, and let's add the subassemblies. Open the tool palettes. You can either go to Menu, General, Tool Palettes window, or you can press Ctrl 3, or you can go to Ribbon Home and click on this icon. I also added this icon to Quick Access Toolbar because that's something I use fairly often. And then let's go to lanes. And the very first lane which is available is a lane superelevation AOR. AOR means axis of rotation. This is the only subassembly that supports more complicated superelevation. Unfortunately, Autodesk didn't develop any other subassemblies for that. But let's right-click on this subassembly and go to Help. Under the Help, you have a brief description. Then you have an attachment point, the input parameters that you can specify, and also their type and default values and all of that. You do also have a target parameters, which means you can override input parameters by target parameters. For example, you can override the lane width or the cross slope by assigning elevation target. There are also output parameters which you can use to override the parameters in the following subassemblies. What it means that you can read the cross slope from the previous subassembly and apply it to the following subassembly. Then you have behavior more in detail. There are some details about the axis of rotation, which I would like to cover a little bit later. There is also some information about the potential pivot point. And what's the most important and why we are here is this point, link, and shape codes. Let me drag this a little bit up, and I will stretch it a little bit down to have a little bit more space. And I will scroll down a bit. And the reason why I did that, because here at the very bottom, we have a coding diagram. Each subassembly consists of points which are connected with the links, and the closed areas are forming shape. So we have a point P1, P2, P3, P4, and so on. And they are connected with the links L1, L2, L3, L4, and so on. And the closed areas are forming shapes S1, S2, S3, S4, and so on. For whatever reason, they decided not to display the shape codes in this diagram. I don't know why, but we know that they are formed by the closed areas. And if I scroll a little bit up, I still want to see P1. So P1 is point at the attachment point, and it is called crown. This is a code. You can also see it as a name. And one point can have multiple names. You can see something similar at the L1, which has two names, top and pave. This is very practical because you want to use link L1 for the top surface. But when it comes to labeling, you want to use the slope in a percentage. While for other links, you want to display, let's say, ratio for cut and fills, you want to display 1 in 2, 1 in 3. While for the paves, you want to see 2%. This will allow you to do that because if the link has a multiple code, you can assign various styles to each code. And that's very important to remember. And you can see that the shapes do also have some names. Let's close the coding diagram. Click on a lane superelevation AOR. If you want, you can specify use superelevation, and we want to use right outside lane because this is on the right hand side, and let's add it to our assembly. If you're asking, is it better to start on the left or on the right? It depends. It shouldn't matter, but in some cases it is better to use on the left hand side because some subassemblies, such a link to mark point, look better when they are placed on the left hand side, but you will see that later on. And then we can escape. Let's zoom in closer and let's see. If you use our template, which uses assembly coded style, the point codes are displayed as a pink names here or pink labels. You can see this is a crown point, crown underscore pave 1, and so on. If we zoom more to the center, you can see the orange labels. Orange labels are for link codes. This one has a top and pave. If the link has more than one code, they are on top of each other. Unfortunately, this is how Civil 3D displays them. And there are also blue labels, and those are for shapes. If I zoom out, you can see this is for shape. This is a base link, and this is a base shape. In our coded style, we don't hatch the areas or layer works, but if you want, you can do that. I will show how to do that in the next exercise. And then if I come in here, you can see that this point has a code ETW, and there are some other codes for other points. You can also see that ETW has a different marker. It is a green cross, while the crown has a green plus. And that's driven by the code set style. I will show you how to do that. Let's explore another subassembly. Go to Basic, right-click on Basic Side Slope Cut Ditch, and go to Help. Again, you have a description, you have an attachment point, you have input parameters, then you have a target parameters. There are no output parameters. Not every subassembly has output parameters. You have a behavior, layout mode operation, so if it is in a layout, if it is in assembly mode, how it operates, and then point, link, and shape codes. And again, this is very important for us. And here we can see that, for example, P1 has two codes, hinge and hinge underscore fill. P2, another codes, then L1 up to L4, top and datum, and L1 represents the fill, so that's why there is a code daylight fill, because you can display different style for fill and different style for cut, which is here. So this is also a coding diagram that will give us more details. You can see the cut condition, how it looks, and fill condition. Let's close the help file and let's add it to our assembly. We can keep the default settings and let's add it to our ETW edge and zoom out. And let's mirror everything to the other side. And select the assembly marker. You can see that this subassembly for slope cut ditch doesn't display any codes. Why? It just displays the layout mode, and some subassemblies behave like that, so it is a little bit more difficult to work with them. I don't really like it much. I would prefer if they displayed nicely what they actually do in various conditions, but Autodesk decided to display it like that, so we must work with it. So sometimes you can't display the codes in the assembly. This is called assembly mode or layout mode. And in the next exercise, I will show you how to customize the appearance of the assembly through the code set style. So save this drawing.